Really snowy morning here. It was nice to wake up to. Just a few things before we get started. Make sure that if you have any questions to type them in the chat window. Also, if you haven't typed your name and where you're from, please put that in there so we can make sure to track participation for the Student Climate Research Campaign. You should see a green speaker icon, and that means that you should be able to hear me. If you have any questions during the webinar, or if you lose connection or something, just send an email to climatecampaign@globe.gov and someone will get back to you to get you going. So today's webinar is taking a look at globe data in action, and we're going to focus on the Africa region for the first in this series. I'm really excited to show what some of the wonderful students from Africa have been doing, and I hope that you get inspired by what they're doing as well. So how we're going to go through the webinar is I'm going to do an introduction to Globe Africa. And from there, I will give 3 different examples of data in action from the region. So I'll take a look at the countries of Mali, Tanzania, and Ethiopia, and what the students have been doing there. And then at the end, I will talk about some upcoming dates for the Student Climate Research Campaign. So Globe Africa is composed of 22 countries, and the first country to join was Senegal in March of 1995, and followed not long after that by the countries of Benin and Chad. And so we've had countries joining for many years. The last one to join was the last 2 to join were in 2005. So we've had some great countries that have joined and have provided a lot of fantastic data. So this region is represented on the Globe International Advisory Committee by Mark Bretney from South Africa. The regional help desk is also located in South Africa. The region also has representation on both the Education Advisory Committee and the Science Advisory Committee. So this region is very well represented on all of those committees. So since the beginning of the program, students in the Africa region have collected and entered over 800,000 data points from over 600 schools. So that's a great turnout from this region. And with all of the data points, you begin to wonder, well, what type of data is being entered and collected by the students, and how can it be used to do research? So as an atmospheric scientist, my first thought is atmospheric data. I know that all the other investigations are really exciting, and I've loved looking at that data too, but just for my background, I wanted to look at atmosphere data first. But there's also hydrology data that's been collected here, as you can see the students in the bottom right-hand picture, and atmosphere data and land cover data, and we'll touch a little bit on those throughout the webinar. So first what I did was, from the Globe visualization system on our website, I just clicked on atmosphere data. So I wanted to see air temperature and how that worked. So what I did was I clicked air temperature data, and then I zoomed in on Africa, and specifically Mali, because I knew that that there was a school in this country who had been a great participant in phase 1 of the Student Climate Research Campaign. So I set the data range to be from the last 3 years. So you can see right here, I also had selected data count instead of measurements, because I just wanted to see, well, where are our top participating schools? And these little orange dots will show you that. So I saw this large dot in the middle of over here in Mali, and this large dot corresponds to over 2,500 data points that they have entered in daily maximum temperature alone. So this school is actually outside of the capital city of Bamako, Mali. So Bamako is characterized by its hot and humid climate, and it's classified as an equatorial savanna with a dry winter. So this means that there's 1 month in the season of winter that has a little bit less rainfall than all the other months. So if you click on this school, if you click on the dots, you will pull up a little information about that school. So this school is Lichi Mamadou Dimabaj di Sabinico. Sorry, I practiced that many times and it still trips me up just a little bit. So if you click on the name of the school here, it'll take you to the school's webpage where you can find information about the school and the teacher, and also see that they are the top participant in the Africa region for phase 1 of the Student Climate Research Campaign. So I thought this was a great school to highlight. So if one of the quickest and best ways to get an idea of how the data collection at the school has been going is to take a look at a time series. And so on this little box here, you can see this little icon at the bottom that looks kind of like two lines. This is the time series line. So if you click on that time series, it will pick up the time that you've plotted over. So this date range that I chose, which is the last 3 years, it'll plot that time series. So this is what came up when I clicked on that time series. And I thought, well, this is a pretty great record. There's a little bit of a gap in here for whatever reason, but in general, you can get a good idea of the annual cycle of daily maximum and daily minimum temperatures. And so during 2012, there were many places in the world that experienced warmer than average temperatures. And so I thought, well, let's take a look at this school and see if we can infer anything about that. So I took a look at this little time period here by this yellow box. So from about August through December of 2012. So what I did was, you can also choose back on this little box, I'll go back just a little bit, you can also choose to, with this pull-down menu, you can download the data. So that's what I did. I just went through and I downloaded the data, and I was able to calculate my monthly averages by using the daily maximum temperature and the daily minimum temperature. So for the months of August through December, I calculated these, which are right here in degrees Celsius, and then I compared that with the normals for the city of Bamako. So I found this information from weather.com, and because it was really difficult to get all of the other information from other places, and they had it such in a great form for me. So these are all in degrees Celsius, and then I just plot a time series from August through December. And so as you can see here from the graph, there's quite a bit of a difference, especially towards the months of November and December, that the observations showed that this school was experiencing warmer than average temperatures. And so this is just one of the things that is really quick and easy to do with students, teaching them how to calculate averages and comparing those with the long-term average of a local city. So one of the really quick and easy ways, and many research projects could come out of this. Well, what's the connection with temperature, or with precipitation, or cloud cover, or any one of those, the many globe protocols that we have. So this was a great example from the school in Mali, and I really enjoy looking at the data and getting, as I say, getting my hands dirty with the things that these students are collecting, and they did a great job doing this. So another example that I'm going to talk about is Tanzania, and as many of you are probably aware, the country of Tanzania is host to the Mount Kilimanjaro expedition. The first expedition occurred in 2008, and that expedition consisted of 15 students, 8 of their family members, and 5 faculty. So this first expedition and the ones since have been very important and very informative for the Globe community. In 2012, the team journeyed from the 23rd of September through the 1st of October up the mountain. So this team gathered environmental data within the distinct biomes of Mount Kilimanjaro. And they looked to the globe protocols to distinguish those biomes. The data that they collected will not only be compared with the previous years, so from 2008 and on, but as well as serve as a baseline for future study areas to examine the effects of climate change that threaten the fragile Kilimanjaro ecosystem. So the team collected various data with respect to air temperature, clouds, surface temperature, soil pH, electrical conductivity, and relative humidity, just to name the globe protocols that they did. One other thing that the team did before they left was they got to meet with some local schools, and it just so happened that a CloudSat passage was about to occur. So the team went to the schools and worked with the students to do a CloudSat observation, which is what you can see here these students are doing on the right-hand side. So this is just taking a picture before they did it, and then here they are taking the observations. So before they even went up and started collecting other data, they were on the ground with the students doing CloudSat. So in order to begin to understand some of the data that they collected, I went to look at Dr. Kenji Yoshikawa's site. He is a research professor at the University of Alaska Fairbanks. His area of research includes permafrost, and Mount Kilimanjaro is a perfect place to look at this. So from his website, I found this really cool image, and I'll explain a little bit about what it is. This image shows ground temperature that was taken with data loggers. And as you'll see, it's a pretty long time series, and it goes from September of 2010 through August of 2012. So they left data loggers, and even though they weren't making these expeditions, these data loggers, kind of like automated weather systems, were collecting data when they couldn't be there. So this image shows a permafrost site at the crater camp, and that's approximately 5,800 meters above sea level, so it's pretty high up there. The temperatures vary really wildly. I'll show you just a little bit and point out a couple places, but this purple line here, where the red arrow is pointing, is the surface temperature, so it's at 0 meters, so you're looking right at ground surface. These lines, which you can barely make out, the red arrow is kind of pointing to, are below the surface. So 1 meter, 2 meters, and 3 meters below the surface. And so you can see that there's not much fluctuation in that temperature, but there is really in the surface temperature. And that's because of the snow cover and the sun intensity. So if you have a lot of clouds, the sun isn't going to be as intense on the surface, and it's not going to warm up as much. You also see seasonal fluctuations, which you have here below the surface, or below the 0 degrees Celsius mark. So it's really, really interesting to see how things have changed. And you can see the seasonal patterns of what's going on top of Kilimanjaro. So this is similar to what you do with the soil protocol. However, you definitely don't go 3 meters below the surface. You're taking samples at 5 and 10 centimeters. But you can still make some really interesting connections between air temperature, cloud cover, 5 centimeters, and 10 centimeters below the surface. So this is a great protocol that if you're not doing, that you can do easily and make some great research projects out of this. So just one other thing to look at with respect to ground temperature and data that they collected on this journey was looking at the difference that altitude makes. So this is also from Dr. Yoshikawa's site, looking at ground temperature data at 1 meter below the surface temperature data. So your red line up at the top is up at that crater camp that I showed you the last slide of. And then you also have the blue line, which is at 4,100 meters above sea level, and the green line was at 4,700 meters above sea level. So as you go down a little bit in altitude, you don't see as much of a fluctuation as you do up above, because it's so highly influenced by the sun and snow cover. Now, one other thing is that this is also the crater camp, so there's some warming that's going on up there from that. So this is just a really quick example of some of the data that's collected on this wonderful expedition that happens in most years. So, with the GLOBE program, we're really looking forward to watching how these things change and continue on through the years, and what research projects come out of this, not only from faculty such as Dr. Yoshikawa at University of Alaska Fairbanks, but also from students in the area who use this data to look at their local climate. So for the final example that I want to talk about today, since it's January, the Climate and Land Cover Intensive Observing Period is going on, and I thought I would look to see, well, have any of the schools in this region participated? Well, as I chose the land cover data entry, so if you're on the visualization system, you can choose what protocol you're going to visualize. So I just chose land cover. I saw that there was an entry from Ethiopia, so you can kind of see it right here, and I zoomed in and clicked on the icon. And so I found that this was the Lucy Academy Preparatory School, and again, you can find out more information on this school by clicking on the link that's provided in this little box. It tells you the measured date and the elevation of the school. And so these photographs are very important for the Climate and Land Cover Observing Period. Land cover observations and photographs that GLOBE schools take are important because these pictures give a perspective from the ground level. These pictures can show landscape characteristics and help determine landscape type. Verification of this is a crucial step in climate models. And so, as you can see, I'll just go back here. There aren't very many pictures in many, many areas of the world. And so it's really important that GLOBE students get out and take pictures so that we can better verify the diverse landscape that our Earth has. There's croplands, needle-leaf forests, grasslands, and the more pictures that students can provide, the more helpful the pictures will be for research. So I just wanted to take a brief look and see what these pictures looked like. And so here's some of the students and the cardinal directions that they took the pictures of. And so from observing this time period that they did, which was one of the first, they were used to compare with satellite imagery to verify their land cover. And so, using this information is great, and scientists are really excited to continue to see this. So if you haven't yet participated in this month's IOP, there's still 2 days left. And so there's plenty of time for you to get outside and take some pictures and submit them to the GLOBE database. So those are just the 3 different examples of some of the way that data can be used, and that data has been used from the Africa region. And as I mentioned, all of the GLOBE data is important, and the stuff that these students have been doing is fantastic. And so just as a reminder, the IOPs are going on. So moving on to upcoming dates that we have for the rest of the campaign in the next few months. As I mentioned, the Climate and Land Cover campaign is going on for the next 2 days, so please go out and take some pictures. Phenology and Climate is also going on. I know as the seasons are about to transition, you might be either about to start bud burst and green up, or you may be looking to going at green down. So going out and starting to take some observations of your study sites are starting to be great now. So from here, we also have some more upcoming webinars. And as I mentioned at the beginning, this is the first in a series of GLOBE data in action, and looking at how student-collected data is being used in the different regions. So you can see the different dates on here. All of this information is on our website. And our next webinar will be on the 12th of February, just giving an update on the SCRC. So some other really exciting upcoming opportunities. The Earth Day video competition, we are starting to accept submissions starting this Friday. So if you haven't already, get out there and start making those Earth Day videos. The link to that is down at the bottom in the GLOBE web links box. So for more information on that, you can check there, and we'll accept those until the 15th of March. Once that concludes, we'll start receiving submissions for the Student Virtual Conference, and that we will take submissions until the 15th of April. The Earth Day video winners will be announced on Earth Day on April 22nd, so we're really excited to share what we know will be wonderful videos from across the GLOBE regions. The Student Science Symposium will be repeating this year at the annual meeting, and so on May 1st, we will start receiving nominations for those from partners, both country coordinators and U.S. partners. So more information about that will be forthcoming, so stay tuned. And then the virtual conference will start on the 6th of May. So there will be some really exciting student presentations. I know we've already received some wonderful ideas, so we're really looking forward to seeing that and sharing that with all of you. And then the annual partner meeting will be held from the 12th to the 16th of August with the partnership at the Goddard Space Flight Center outside of Washington, D.C. So those are just some really fun upcoming things that are going on, and we're looking forward to seeing all of the wonderful research projects that the community has been doing. So thank you for attending. Again, the next webinar will be on the 12th of February, and at this time I can take any questions. Yes, Becky, the students in Africa have been doing a great job, and I was really excited to be able to share what they've been doing. Well, if there are no questions, I'd like to thank you again, you all, for coming and attending the webinar this morning. We'll stick around for a little while, so if you have any questions that come up, feel free to type them in and we can get back to you for that way. But again, hope to see you all on the 12th of February. Thanks.